Today is the last class for this semester. We want to learn about the logarithm. B to the power x is the exponential function. The inverse function is the log bx. How do we get from here to here? We make y equals to b to the power x. And then we switch x and y. Y change to x, x change to y. But if we want to solve the y equals to log bx. So for example, 2 to the power 3 is 8. Then log 2, 8 equals to 3. So when you see here, you want to immediately write down 2 to the power 3 equals to 8. After you write down this y, you can change the y to f inverse x. This equals log bx. Now, if I give you this, we want to be able to figure out the inverse function, okay? Let me call student Aiden. Let's do the first one. Find out the inverse function, please.
The first step would be to switch x and y. So x equals 2 to the power, no, x equals 5 to the power of 2y plus 4. And then you subtract 4 from each side. So x minus 4 equals to 5 to the power of 2y. And then after that, don't you do
you make a 2y, okay?
Yeah,
2y equals to what?
Equals to log base 5 of x minus 4.
Okay. Log base 5 of x minus 4.
And then you divide by 2.
Step.
Divide by 2. Yeah. Y equals to log base 5 of x minus 4 over 2.
That's it. Okay. So this is the way we do the inverse function.
F negative 1 of x equals to. Yeah.
Now let me call the next student, Brian.
Yes.
Let's do this one.
Okay.
Yeah, we first replace this by y equals to this, okay? And then we want to switch x and y. Go ahead, please.
So x equals ln x, or wait, yeah, sorry. X equals ln xy plus 1.
Okay, next. You want to solve your y, so you want to minus 1 on the other side. X minus 1 equals?
Equals 6.
Ln 6y, right? Okay. What's this? Ln. This is the natural log. That means it is log ex, okay? So if you have log 10x, by default, you don't need to write down 10. You say log x. If you have ln x, that means you have your base of e, okay? And this means log base e of x. Now, if you want to find out this y, what does this mean? This means the base here is e. So 6y will equals e to the power of x minus 1. Does this make sense?
Yes.
If you feel confused about here, you can rewrite. That guy is always equals to the base to the power of this. And then you write down y equals to 1 over 6 times e to the power of x minus 1. And then next step, you do F inverse. Okay, that's it. Does this make sense now?
Yes.
Okay. Now, we want to be able to draw those graphs. Last week, I teach everybody to draw e to the power of x, and then we change like e to the power of negative x plus 3, and then plus 2, and then in front there is a 1/2. Yeah, I teach everybody the way to draw that, and today we need to draw question like this. So let me show you how do we draw this one. Okay. Without calculator, we need to draw this by hand. The way I draw this one is Brandon. Brandon.
Hello.
Yes. I make the x minus 1 equals to 2, 1, and 1/2. The reason is because log base 2 of 2 equals how much? If this is 2, how much is this? Log 2 equals how much? Log 2 is 1, right?
Yeah.
Look. Log 2 is 1 because 2, this is the base, this is the exponent. 2 to the power 1 equals to 2. That's why here is 1. Does this make sense to you?
Yes.
And then you times 3 and minus 4. How much here?
-1.
Negative 1. Very good. Next one is log base 2 of 1. How much?
1.
2 to the power what equals to 1? Two to the power 0 equals to 1, right?
Oh yeah, that's right.
When you write down this, when you feel confused, you don't know what's the answer, you rethink this question. You are always looking for that guy to the power that equals this. This guy to the power 0 equals to 1, okay? Just like before you learn the division, you learn the multiplication. And then when you do the division, you always feel hard, but you can think the multiplication way to figure out the division result, all right?
Yeah.
So you put here as 0. So this equals?
-4.
Really? That's 0. 3 times 0 is 0. 0 minus 4 is how much? -4, right?
Yeah.
Okay. One more. What should I put here? What should I put here?
Is it -1?
Very good, because 2 to the power -1 is 1/2. That's why here is -1, okay? And then this is -1. Plug in here, how much?
-7.
-7. And then this is x minus 1. How much is here?
3.
Good. Next,
2.
next.
1 and 1/2.
Okay. 3 over 2. Now we have 3 points. 3, negative 1. So when my x is at 3, this guy should be at negative 1. Okay, let me draw here. When x is 3, I'm at the location of negative 1, that location. When it is 2, I'm at negative 4. When it is at 1.5, it is at negative 7. And then I'm going to cross. I'm going to cross the points with a smooth line. All right. Let's also figure out the asymptote. For logarithm, the asymptote is this guy. Yeah, you cannot make this guy less than 0. The guy over here is always positive. What's the reason that this guy is positive? It is because, look at here. Y equals to 2 to the power x. That guy. This is the asymptote. That guy is always above 0. So this is always bigger than 0. So when you do the inverse function, log 2x, this guy is a y value. This is always positive. That's why this guy inside is always positive. So who is the asymptote? You make this equal 0. That's your asymptote equation. So your asymptote equation, this is your asymptote equation. For the exponential, you have the horizontal asymptote. For the logarithm, you will have the vertical asymptote. You make this equal 0, you make x equals 1. This is your vertical asymptote, VA, okay? Vertical asymptote. So you draw x equals to 1 as here. And then you connect these 3 points. That's what your log function looks like. Does this make sense to you, Brandon?
Yeah, makes sense.
What's the reason I want to draw the graph like this way? So student might say, why I cannot just choose x equals 1, 2, 3 to draw the graph? You can try. If you try the x equals to 1, so if x equals to 1, then x equals to 1, you notice that. So let me show you. If x equals to 1, x minus 1 equals to 0. Log 2, 0 does not exist, okay? This one not exist, so you cannot get the value. You say, it's okay, I'm going to make x equals 2. Yes, you can do this. X equals 2, then you do 3 times log 2, 1 minus 4. That's okay. Log 2, 1 is 0. So this is negative 4, no problem. Then you say, I'm going to make x equals 3. You will see log 3 times log 2. 3 minus 1 is 2. And then minus 4. So this is 3 minus 4. Yeah, you still can do it. And then we do x equals to 4. This becomes 3 log 2. 4 minus 1 is 3. Without calculator, how do you know how much this is? You won't be able to find out this value. Log 2, 3, you will not be able to find the value without calculator. So you're stuck here. You won't be able to get the point. You say, I'm going to just draw the line by 2 points. No, you cannot draw a curve by 2 points, okay? A straight line, yes, you can use 2 points to decide a straight line. For a curve, you need at least 3 points and an asymptote to draw the curve, okay? So this is the quickest way to draw. It doesn't matter how complicated your expression looks like. You can always make this package go to 1, 0, -1, and you go this direction, you go that direction, and you easily find out your 3 points. This method can be applied to all those exponential, logarithm, trigonometry functions. Now, next graph. Fx equals this. Yeah, you want to draw this one. So I will erase my stuff here. And students, you can go ahead, do it. I need everybody type in your answers for the 3 points. For example, based on this point, you tell me x equals how much, and this y value equals how much. So I need you to give me, 3 points coordinates and text me in the message. Start now. ln is called a ln. That is just as log e, okay? How much is e? E is this number. This is 1, this is e to the power 1. This is 0, this is e to the power 0. This is -1, this guy is e to the power -1. And then you will extend to this side. On the other side, you just put a negative in front and then you plus 2. You will get 3 points in pairs. Very good. I already have one student, Olivia, type me the answer. Olivia, you can double check your answer and then you go ahead. You can draw it in the coordinates, okay? Listing the table using the simplest number and draw the graph. is a very important and useful techniques. If you have siblings who are going to take those AP calculus, AB or BC test in May this year, they have those kind of very complicated questions. The most difficult part for calculus BC among all the high school topic is those Taylor series and the Maclaurin series. And for doing that question, that type of question is more than 20% of the whole AP 4 hours test. In those questions, listing those tables correctly is the starting point. If you get that thing wrong, everything is wrong. So make sure you do have mastered the skill I teach you over here. Really? Only one student know how to do this? If this is 1, x plus 1 will equals to e to the power 1. So x plus 1 equals to e. If this guy is 0, x plus 1 will equals to e to the power 0, which is 1. If this is negative 1, that guy will equals to e to the power negative 1, which is 1 over e. So you have these 3 points. You have this plus 1, so x will be e minus 1. Here is 1 minus 1, go to 0. And 1 over e minus 1, go here. And on the other direction, you have negative of this guy, plus 2. So this is negative 1 plus 2. Here is 0 plus 2. Here is negative of negative 1 plus 2. So you got 1, 2, 3. On the left, you want to know e is how much? E is about 2.71828, okay? Why this guy is so important? In math, there is a formula called the most beautiful mathematical formula. It's called Euler equation. E to the power of I times pi plus 1 equals to 0. This is called Euler equation, okay? That's called the most beautiful mathematical equation. Why? Because in elementary school, you learned integers and then the whole number, natural number, whole number, then integers. Then we start to learn about irrational numbers. Pi and e is irrational numbers. And in high school, we learn the imaginary numbers. Euler equation connect all those numbers into a very simple equation. By the time you learn AP calculus, after you learn those Taylor series, you will understand why this is always true, okay? So E is a very powerful tool. E is about 2.71828. And it never repeat, just like pi. You don't have a pattern for this. And you can roughly use 2.7 to draw your graph. So the first point you have is 1.7, 1, 0, 2, negative 0.58, 3. So you got 3 points, and you want to make sure you have the correct asymptote. You make this equals 0, x equals -1. That's the asymptote. And then you go like that. That's how we draw the graph here. Is there any questions? Make sure, do those practice, finish drawing using the 3-point way, okay? 3-point table to finish drawing those logarithm graph. Now, we are going to see more question, one more examples. Go ahead. Use the way I show you here and show me your 3-point. Based on here, you push to this left, and then you get your answer here. You push all the way to the left, to the way right, and then tell me that point, that point, that point, that point, that point, that point. Text me your answers. Just now, the previous question, only Olivia finished it correctly. If you still don't know how to do it, this is the time to ask me. Olivia get the 3. Who else? Ryan also get it. That's great. Yeah, Olivia and Ryan, you can see the graph I draw on the left. On the left, this is e to the power x, okay? E to the power x. And on the top, this is a polynomial. This is those polynomials we learned previously. And this polynomial is very interesting. Yeah, it's kind of like very long, very complicated, but I can simulate e to the power x by a polynomial, okay? So this is really cool, you see? These two has different expression. How come their graph looks like identical? That's called, the first polynomial is the Maclaurin series of e to the power x. And how do we get e? If we make x equals to 1, if x equals to 1, this is 2.718. If I make x equals to 1, if I call this guy if I call this as fx equals this, and then I do f1, you see, these two numbers are so close, okay? So what's e? E is calculated by this. E is equals to 1 plus 1 plus 1 over 2 plus 1 over 3 factorial plus 1 over 4 factorial plus 1 over 5 factorial. Continue, okay? Yeah. If you continue plus all those number factorials, fraction with infinite number, that's the number of e, okay? So if you continue going up, the number will be more close to the real value of e, all right? Yeah, just like pi, you will not be able to see the last number of e. It's infinite, many. Well, I know this knowledge is beyond this class, but I do encourage you to know something interesting that you may learn in AP Math or college, okay? Factorial means what? 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. 4 factorial is 4 times 3 times 2 times 1 up to 1, okay? So this is 24. Yeah, you can do those experiments. It's very interesting. So anybody finish this part? Only 2 students get it. Only 2 students can find the 3 points. Eric, that's just 1 point. Continue find the other point. -3, 2, perfect. -2, -2, perfect. -3 over 2, -6. Very good, Eric. You made it. Thank you. So you trace these 3 points, connect them by a smooth curve. Who is asymptote, Eric Liu? Who is asymptote? How do you get the asymptote, Eric? Eric, how do you get the asymptote?
You find that it's x minus 1 and then it's reflected, so it's -1.
Yeah, you make this guy equal 0. Negative x minus 1 equals 0. So x equals to -1. So that's the asymptote. Okay, that's asymptote. And then you connect this. That's how you get here. Some students may feel confused. Why the log graph sometimes going down, sometimes going up? What happened? It is because, look, your original exponential function going up like that. As the inverse function, it's going to be reflected over the y equals to x. So the inverse function going like this. Between here and here, what happened? You shift to the right by 1. So this guy shift to the right by 1. And you have a vertical stretch by 3. So you got a vertical stretch by 3. And then you shift down by 4. Then you shift down by 4. That's why the graph here looks like this. All right? Because the original one is going up, increasing. This guy just have a vertical stretch and a vertical shift down. So it is still going up, increasing. What happened to this one? Why is this guy going down? It is because as originally ln x looks similar, something like that. But you have a horizontal shift to the left by 1. So you get here. This is ln x plus 1. And you have a negative in front. So that is a reflection over the x-axis. So you got a line like that. And then you shift up by 2. So you got here. That's why the graph final looks like this. For the latest question we did just now, this guy, your original one is log 2x. Log 2x will be like this. That's your parent function. And then you have what? You have a negative x plus 1. So what does this guy do? This guy will have a shift to the left by 1. And then you have a reflection over the x equals to -1. So you becomes to like that way, okay? And then you have a vertical stretch. You have vertical stretch, and then you shift down by 2. So that's how your graph looks like based on those transformations. There are still many other practice. What will happen if you have a number as a base which is between 0 and 1? When you have 2 to the power x, your exponential function go like this. When you have 1/2 of x to the power x, you have those exponential decay. Remember, a to the power x, when a is bigger than 1, you do exponential increase. Like you put the money in the bank, they give you interest. You have those compound interest. Your money is growing. All same thing like coronavirus. It's growing exponentially. But if you buy a car, your car's price will depreciate. So it's going to going down. This is exponential decay. So as a log base of 1/2, your log base of 1/2, your graph will look like that way, okay? It looks like that way. That's why this graph looks like that. Your parent function is this. And then you shift to the right by 2. You shift to the right by 2. And then you shift down by 3. you shift down by 3. Your asymptote is always using this guy equals 0, so your x equals 2. That's how we graph here. We still use the same method to draw it. We make this guy equals -1, 0, and 1. And then you should be able to find out -1 minus 3, -4. 0 minus 3, -3. 1 minus 3, -2. And based on this, you should be able to get x minus 2 equals to what? And then x equals to what? Okay. So those questions are not hard. I list all the details for how to do this. But you do need to remember E is roughly 2.7 for you to draw the graph, okay? You need to know that. Now we have more practice here. Now I need to teach students question like this. Eric Shaw. Number 9. Tell me how you want to do this one. Square root 6 is a base, so that means x equals square 6 to the power of 4. Okay. From here, what do you do next?
That would mean it would just be x would equal 6 to the power of 2.
Yes, equals
36.
That's it. Thank you. Hey, Eric Shaw, one more question. Let's do number 11. How do I solve this one?
So x squared plus 21x. I mean,
Equals
I think
this log by default it is 10. Okay. So
10 to the power of 2,
yes, which is
100.
now show me how you factor in this one. Go ahead. How do you solve this one? How do you factor in? 1, 1,
Yes.
4. $1. How many quarter?
4.
So
25x. Wait,
so
minus.
that means this is negative, right?
Yes.
So x equals to 4 or
Negative
negative 25. Correct?
Yes.
But we want to double check to make sure we need this guy to be positive, okay? This is positive, that's positive. So when x equals 4, this is bigger than 0, no problem. This is negative 25. Negative 25 squared plus 21 times negative 25.
That equals
This
100.
guy, this is bigger than 0. Yeah, this is 100. So that's the 2 answer. We want to keep both. All right. Make sense?
Yes.
Okay. Let me call the next student. Ted. Number 13.
Yeah.
Tell me, how do I write down the equation? What should I write as the equation? X to the power of, that's the base, that's the exponents. X to the power of,
Negative 3/4.
good, equals
27.
27 is who?
3
3 to the power of,
3 to the power of 3.
3 to the power of 3. So I'm going to rewrite this, okay? Correct?
Yeah.
Now, x to the power of this equals to 3, right? Correct?
Yeah.
What do I do next? What do you want to do? If you cannot figure out this, you want to call other students to help you. Who you want to call? You can call Olivia, you can call Ryan, you can call Aiden, you can call Eric and Brandon. Who do you choose?
I just choose Eric.
Who?
Eric.
Eric. Eric Liu or Eric Shaw?
Lil.
Okay, Eric Liu, it's your turn. Tell us how you solve from here.
Oh wait. You just you look like you multiply it by like -4 or something. Wait, no, not negative. Wait, yeah. You like you take the power of -4, or like you
You can do this by doing a power of -4 again, right?
yeah.
Then this times this canceled to be 1. So that is x, yes?
Yeah.
How much is this?
1/81.
That's it. Yes, good job. See, you can make it. Let me call the next student, okay? Lucas,
Okay.
let's do 23. Go ahead, please. Two x to the power of what? Lucas, -3 equals
81.
81. 81 is who?
3 4.
Uh,
And
81 is 3 to the power of 4, I think.
Yeah.
This is 3 to the power of 4, right?
Yeah.
Okay. Now, we have 2 to the power of x. Hold on, okay. We have 2 to the power of x. Then we can do the fraction. We can do this guy to the power of a negative 1/3, right? Yes,
Yeah.
does that make sense?
Oh,
So this becomes to 3 to the power of 4 times negative 1/3. Does this make sense to you?
yeah.
Okay. Then this is 2 to the power of x equals to what?
That equals to
3 to the power of negative 4/3, right?
yes.
So far, so good.
Yeah.
Next, let's see. Who is 3 to the power of negative 4/3? That is 1/3 to the power of 4/3, right?
Yeah.
Okay. And then x will be what? X will be log 2. And then 1/3 to the power of 4/3. Okay.
Okay.
So far, so good.
Yeah.
Now let's do next one. Aiden, let's do number 16.
Okay. Okay. So if the natural log of 8x plus 16 equals to the natural log of x squared plus 7x plus 10, then there's no need for the natural logs. 8x plus 16 equals to x squared plus 7x plus 10. So you probably, yeah, just cross out the natural logs. I guess I would start by like factoring them, I guess. So 8 times.
Yeah, let's move them to one side first.
So x squared. I'm gonna subtract 8x plus 16.
Yes.
Or yeah, so 8x. So it's negative 8x minus 16. So x squared minus x minus 6 equals 0.
Okay.
And then x minus 3x plus 2 equals 0. So the answers could either be 3 or -2, but it can't be -2. So
Very good.
it's 3.
Negative 2 times 8 plus 16 equals 0. So we need to cross out this answer. Okay.
Yeah.
That makes sense.
Yes. So that's the answer.
Okay.
3.
Yeah. Very good. And I think it's close to the final. So let me summarize all those logarithm properties. Okay. When we learned those exponentials, we have this, which is a to the power x plus y. The corresponding logarithm for this is log ax plus log ay equals to log ax times y. Okay. If we have a to the power x divided by a to the power y, this is a to the power x minus y. And then we have log ax minus log ay equals to log a x over y. Okay. I believe students are very comfortable with this too, but you might feel confused about here. So I'm going to quickly prove this to you, why this is true, okay? I record this class for videos. So if there's any places you feel confused, you can look at it again and practice. I make this guy called M. I make this guy called N. By the log definition, x equals to a to the power of m, y equals to a to the power of n. Then this guy here will equals log a, x is a to the power m, y is a to the power n. This is log a to the power of m plus n. This guy as an exponent can safely go to the front. So we will pull out m plus n to the front, and then the leftover is log AA. Log AA is 1, so this is m plus n. M plus n, m plus n. That's how I prove this. So this is correct. Look, x, y product log is equals to these two together. There are many students, they do those crazy formulas. They do x plus y here. This equals log ax plus log ay. Listen, this is horrible wrong, okay? This guy is horribly wrong. Don't write down this. This is crazy. This is something very wrong. That's not true. The way is, if you have a product, you can split them into this. From this direction to this direction is called expand, okay? It's called expand. From this direction to this direction, this is called collapse, okay? But I never ever teach you this formula. This one you cannot do. Yeah, you leave it as it is. You don't do this direction. Now I'm going to prove this one. I still make this guy called m, this part called n. Students, if you are already in Algebra 2, if you feel the logarithm part a big headache, don't just skip, okay? Because in pre-calculus, you will see their friend logarithm again, and it's going to be even harder. If you don't understand now, this is the time for you to pick it up. Don't let hard thing to build up. At one point, you will never be able to finish. You pull out m minus n in front. So again, this is m minus n. Okay, so this is first property, second property. Next one. A to the power 1 equals to a. So log a equals to 1. A to the power 0 is 1. So log a1 equals to 0. Okay. If you have log a to the power x, this guy is going to equals to x. You might ask me, why, teacher, you can do that? Look, by the definition of log, a to the power x equals to this. I say one more time, a to the power x is this. A to the power x, of course, equals to a to the power x. So if you treat one of them as a base, then this guy is true. This guy is always true. Okay? Now, log ax equals to log ax. Log ax equals log ax. That's always true. It is equals to itself. Reflexive property. Then this guy, you pull it here. This guy to the power of that guy will equals to this guy again. So you have a to the power of log ax equals to x. A to the power of log ax equals to x. As long as you have a two base the same, the value is exactly that guy. Okay, I'm teaching you people the most important formulas for logarithm. All of this should be included for your final of Algebra 2. Next one might be the most important one, is the base change rule. Log ax, log ax. I'm going to make it equals to log bx over log ba. Okay. I can choose my b to be any positive numbers. You say, teacher, can I make b equals 10? Of course, you can make your b equals to 10. If you make your b equals 10, that's going to be log x. By default, if it's 10, you don't need to write. Okay? If I don't write any base number here, by default, this guy is 10. You say, teacher, can I use natural log? Of course, you can do it. You can do ln x over ln a. Okay? You see, really? I don't believe it. For example, can I say log 2x equals ln x over ln 2? Is this really true? Of course, this is really true. Okay, this is log 2x. This is the ln x. You say, teacher, they are not the same. Of course, you haven't divided by ln 2 yet. Oh, they are identical. Did you notice that? They are identical, okay? So I can share a small joke here. I have a baby, okay? Right now she is 5 years old, but back to 3 years ago, she was just 2 years old. So one day, I have a very expensive TI Inspire calculator. One day, the baby put all her butt on my calculator and changed my TI Inspire into the test mode. Test mode means you are not allowed to type in a log AX. You can only type in either log X or ln X. So I'm not able to do my calculation of log 3x. So what I do, I have to do ln X over ln 3. Or I have to do log X over log 3. Okay? Well, for changing my TI Inspire calculator back to the normal mode, I have to either buy a very expensive cable to connect the two TI Inspire calculator together to recover, or I have to download a software and install on my computer and do some debug to fix it. But finally, I fix it. So that's what's going on with the test mode of TI Inspire calculator. So don't mess up with your calculator, okay? Otherwise, it's very painful to fix it. Now, I'm going to prove why this is always true. You already see it, it's true. And now I'm going to prove why this guy is always true. I'm going to say m equals to log ax. If m is equals to log ax, then x equals to a to the power of m. Okay, so log bx will equals log b as base and then a to the power of m. We can put this guy in front. That becomes to m times log b a. Now let's do here. So that guy will equals, this will be replaced by here. So let's plug in. This over log BA. This and this are exactly the same, and they are non-zero numbers that can cancel. So this equals to m. This equals to m. And on your left, that's m. On your right, that is also m. That's why this is correct. Okay, that's why this is correct. This is called base change rule. Base change rule. This is a critical important formula that you have to master. Okay, you have to master this. And you already noticed that. You see here, these two graphs are identical. If you do the other one, if you do the log base 10, this guy divided by log base 10, and then you do a 2 here. Okay, watch out. They are identical. They are the same. Yeah, we already proved which is true. So you have to also remember this, okay? Before you take the final, make sure you can write down this formula and truly understand how you can apply this formula. Okay. All those questions are based on those properties that I listed to you. Let's see one more questions. Look at here. That guy is going to equals to 3 to the power 2. So 9x plus 10 over 5x equals to 3 to the power 2, which is 9. Yes? And then 9x plus 10 equals to 45x. And then 10 equals 36x. That's why you can get x equals to 10 over 36, which is 5 over 18. Okay. So let me summarize again. We learned about exponential graphing. and logarithm graphing. Yeah. For the exponential graph, you don't want to just choose x equals to 1 and then 2 and 3, because that's not the best points for you to draw the curves. The best 3 points to draw the curve is the 3 simplest point. Who are the 3 simplest point? You look at your function. You make this guy, list them, and you make that guy equals to -1, 0, and 1. And you push this way to get your x, and you push the other way to get your y. As -1, 0, and 1, this is easy. This is 1/3. This guy, of course, is 1. This guy is 3. And then you do those following operations. You can easily get this part. This part to get here, not hard, you times 2. Then you get the first pair, second pair, third pair, and then you mark it. As a curve, we already say 2 points, you cannot draw a curve. 2 points, you draw a straight line. 3 points with an asymptote, you get a curve. Who is the asymptote? This will never be 0. That's why the asymptote here is y equals to -2. And then you draw it. Will the curve cross this asymptote? No way. It's going to stay on this side. Okay, that's how we draw the exponential functions. How do we draw the logarithms? We mix this guy. We make this guy. We first list this. List this -1, 0, and 1. And we push this direction. And then we push the other direction. You keep pushing until you reach your final answer of x. You keep doing the other direction until you reach to the y. Okay, yeah, because you need to times 9 and plus 1. After you get the 3 points pair, you draw it. You might ask me why this guy looks so weird, because they have a vertical stretch of 9. That's why this is so steep. And then we do some kind of equation problem. I believe this part is not as hard as the graphing part. And the last, but the most important, all these property formulas, everybody, you have to master it. If you don't master now, pre-calc, you have to redo it, okay? Don't delay. That's the last class for the Algebra 2 for this semester. I wish everybody have a successful final, okay? And then relax a little bit for the summer and then ready for your next semester. Okay, yeah. Algebra 2 students, you can leave, okay? Good luck for your final, bye-bye.